right, we are doing similar triangles homework, and we're starting with number 6. So let's take inventory. What do we know about these triangles in number 6? Okay, well, we know they're right triangles. So they have an angle in common. They have that going for them. Are all right triangles similar? That could be a question we could ask you on the test. Always, sometimes, or never. Right triangles are similar. Well, to be similar, by one of the theorems we learned, you have to have two angles congruent. And for all we know, this could be 20 and 70, and this could be 30 and 60, or vice versa. We don't know those other two angles. We do not have enough information. They're not even sharing a side, right? They're sharing like a part of a side. They're adjacent, but all we have is an A. So we don't have near enough information. So I would say none of the triangles are similar, or NP, not possible. Number 7 is a different story. In number 7, we know some side lengths. Now that doesn't make it side angle side. I don't want you on number 7 to write side angle side and move on, even though we do have two sides and an angle in between. You have to check to make sure the sides are proportional. The trick to this one is you have to use the 6 twice. That 6 is the smaller leg of the blue triangle, and it's the longer leg of the red triangle. So I'm going to do small over small equals the longer one over the longer one. So go to the blue triangle, the smallest leg, 6. Red triangle, smallest leg, 4. Now blue triangle, longest leg, 9. Red triangle, longest leg, 6. So 6 is to 4 as 9 is to 6. This is actually called a geometrical mean, and we'll learn about it after Christmas. But anyway, if we cross multiply, or if we reduce both of those fractions, we would get, what, 3 halves both times? So, yep, they are similar by side, angle, side similarity. 16, so this is taking similar triangles and putting it in the context of a word problem. If a 60-inch tall Madeline casts an 84-inch shadow, then how tall is her friend if at the same time his shadow is 12 inches shorter than hers? Draw a picture. I would just start by drawing 2 separate triangles. Now, when you're standing up on the ground, you're always allowed to assume that you're standing at a 90-degree angle with the ground, that you're not like leaning over like that, okay? Your feet are at least 90 degrees to the ground. So, we've got Madeline, she's 60 inches tall, and her shadow is 84 inches. We've got her friend that is 12 inches shorter than hers. So 84 minus 12, 72, find her friend's height. Now, we are actually not allowed to set up proportions unless our triangles are similar. But what we could have done is put these, their shadows are going to end at the same spot. So we could have put one inside the other, and they would have been similar by angle. You don't really have to know that, but I'm just pointing that out. They're similar by angle. Okay, anyway, so now that we know that they're similar, we're allowed to set up a proportion. Height is to height, x is to 60 as, 72 is to 84. So I put height is to height as shadow is to shadow. Doesn't matter where you started. You can write that proportion like 5 different ways. So it doesn't matter where you started as long as you're consistent on the right and the left. So then you just cross multiply and you know his height. When a mirror is placed on the ground so that the top of a building can be seen by a person standing by the mirror, the measure of angle BMA equals the measure of angle BMC. So these are not vertical angles, but in the problem they're telling me they're equal because of where the person is standing. So I am going to add arc markings, and then remember we assume that buildings are not the leaning tower of Pisa, that they are perpendicular to the ground, and that people are perpendicular to the ground. So there we go. Those triangles are already similar by angle similarity. A person 150 meters tall, who is 6 meters from the mirror, observes the top of the tower when the mirror is 120 meters from the tower. So this problem is all about putting your data in the right spot, labeling your picture correctly. Then you can set up your proportion and cross multiply. Same thing as last time, find the height. So I could do height is to height as shadow is to shadow. Make sure you cross multiply and you put units on your answer. Oh, good catch. So glad you said that. 150 centimeters? Wow, interesting. Good job. That would totally not make sense for him to be 150 meters tall. That person would not exist. Thank you. Smart. All right, there you go. Now cross multiply. And your answer will make a lot more sense than it would have made when I set it up. Good catch.